So we solved this problem using numbers regarding potential energy, kinetic energy, and thermal energy. What we're going to learn to do now is to make an LOL diagram of what happened in that problem. And to do that, I'm going to just show you how to do that in this video. We go to the drawing, we go to new, and now I can draw. Now there's about 4 parts that you need to do to actually complete a LOL diagram. The first thing you need to do is you need to draw what's happening. And I use Scribble a lot. Your drawings don't have to be perfectly beautiful. And so I am going to go ahead and just draw what this situation looks like. We started out with a rock on a hill. So there's my rock on a hill. The real reason I'm drawing this hill for this rock going down is I need to say where 0 is, all right? And this is my 0 height, okay? So 0 equals the height, all right? So 0 meters here, all right? So we can tell it's not the rock, but it's the height of that rock, all right? So that's where it would have 0 potential energy, and I'm hoping my scribble will stay this time, all right? So you got to write that because we need to know if this has potential energy up here or not. And it does because 0 height is here, so that must be higher than 0 height. All right, now we're going to make an LOL diagram. This does not need to be perfectly beautiful. There's my L, there's my O, and there's my L. All right, now in this LOL diagram, this is actually a graph, and on this side of the graph is energy, and this is the start. This is the starting drawing, and this is the ending drawing, all right, for what happened to my rock, all right? And so I'm going to draw what's happening to my rock, but I have to do one more thing first, and that is I need to tell what the system is. You've done that before in some of your diagrams, your pie charts. You needed to tell what the system is. Well, what is in my system here? Well, there's a rock, but it wouldn't have any potential energy if there weren't Earth's gravity. So Earth must be part of this also. So I'm going to write that there's a rock, and I'm just writing an R here. All right, I think you can tell what that is. I'm just trying to make this easier so it's not too hard for you to draw. And I'm writing the Earth, okay? So that's my system, all right? Finally, I'm going to write in the energy that this rock has, all right? Well, it could have all sorts of types of energy. And again, you guys might want to abbreviate here. I'm going to allow you to write just G for gravity, gravitational potential energy. You can write K if you'd like for kinetic energy, all right? And you can write a T for thermal energy. If you don't draw the lines a little bit crooked, it won't stay. All right, so there is my LOL diagram. Remember, this is a graph, so there needs to be some lines across here. I'm going to draw 4 lines across this drawing. Whoa, that was supposed to be a straight line. It's not very straight. These should be equally distanced apart. I'm doing the best I can to do that. All right, now, starting out, what kind of energy did this rock have? Well, the only kind of energy it had was gravitational potential energy. So I'm going to draw in this chart, I'm going to draw that it has gravitational potential energy. And I'm doing this by making a bar chart, all right? So there we have it. There's how much gravitational potential energy it had. Now, remember the problem. The problem says that the rock goes down the hill till it gets to 0 meters, and then there's no energy left. That's gravitational potential energy. But it is stored as kinetic energy and thermal energy. So I'm going to go over here, and I'm going to draw what I had in this drawing. So going over here, I have to draw my 4 lines again. Sorry, that one's so ugly. It should be straight across. Do the best you can. I'm running out of time because I only get 5 minutes to make this video. All right, so how much energy is it going to have of kinetic energy? Well, kinetic energy on this side, is going to be this much. There you have it. And then the thermal energy on this side is going to be also that same amount. Notice I'm putting in 2 bars, okay, of energy because they should equal the 4 bars on the other side, all right? So energy before equals energy after. There's your LOL diagram.